This is a wheat field in China after an insect attack.
This is a cornfield in the United States after an insect attack.
This is a rice field in Taiwan after an insect.
This is a coffee tree in Uganda after an insect attack.
This is a grape tree in Spain after an insect.
This is a soybean field in Argentina after an insect attack.
Harmful insects are causing great damage to our lives.
Each year, agricultural loss caused by insect damage alone is $470 billion.
20% of the annual crop production is destroyed by harmful insects.
If some of this food can be saved from insect damage, it can be used to feed the more than 3 billion people who are starving around the world every day.
Insect damage has always been a problem and will continue to be a problem even with advanced technology nowadays.
This problem has to be solved, and people are trying.
However, our current solution is pesticides. 3 billion tons of pesticides is being applied each year on crops.
Pesticides can cause severe health problems such as birth defects, nerve damage, and cancer. It is also greatly damaging our environment in all its forms of devastation. We are the 2014 NCTU Formosa agent team.
We need a change.
Good afternoon, ladies and gentlemen. I am Supervisory Special Agent Rachel Lee.
And I'm Supervisory Special Agent Nick Shaw.
We are from the Harmful Insect Elimination Force of NCTU Formosa. Today, we are here to brief you on our latest assignment that is going to save the world, Operation Debug. The purpose of the existence of our task force is to eliminate the devastating problems caused by insect damage.
Hundreds of thousands of hectares of production are wasted around the world every year.
Currently, our solution is pesticide. How lousy solution it is.
9.6 billion US dollars are lost on the damage of pesticides every year.
Our goal is to resolve insect damage without the terrible side effects of pesticides.
In this operation, we are mainly targeting Oriental Formosa. Its main area of activity is tropical islands, and major part of the damage is done in Taiwan.
This insect is highly dangerous and it is seriously threatening our nation's security. It feeds on over 40 families of plants, which basically includes almost everything.
It is a danger to every crop.
And we are hunting it down. To put our operation into motion, we need a tactical plan. Currently, the most commonly used method to attract and capture insects are the pheromone trap. As we all know, pheromones are the hormones of insects, originally used for mating and certain other purposes, and it can specifically attract insects. So that's what we wanted to do initially, to biologically synthesize pheromone traps to replace the chemically synthesized ones currently in use. However, we found the biosynthetic pathway of pheromones way too complicated and stressful for E. coli to execute. It is practically impossible for this plan to work, so this mission plan was aborted. We started looking for a plan B, and we decided on infiltration. We are sending in an undercover agent, PBAN, whose full name is Pheromone Biosynthesis Activating Neuropeptide. Agent PBAN will turn the target insects against themselves, prompt them to make pheromones for us, and attract more of the target insect for us. So, how exactly is that going to work? Well, here we have the pheromone gland of our target insect. Once the PBAN binds with the receptor on the gland, biosynthesis will be activated, and pheromones will be emitted. So forget all of this. Let the insects do the job for us. They are naturally designed to do so, after all. All we have to do is produce a simple peptide through transcription and translation. Now, I would like to give more information as to why we chose Agent PBAN for our operation. A lot of it has to do with its identity. It is a simple, small peptide. Its being a peptide means that it can be biologically synthesized simply through expression of E. coli. The fact that it is smaller than 150 base pairs is yet another plus any stress for E. coli to express it. Its being a peptide also means that it is not afraid to be degraded because it's already in a very simple form. Now, the most important part is that it is specific. P-band has the same species specificity as pheromones. One kind of P-band can only bind with one kind of insect who will release its own pheromones and attract more of the same very kind of insect. So if we allow 3 different kinds of insect to react with the same kind of P-band, only the corresponding kind will have a reaction. In this case, we're using the moth's P-band. So nothing will happen to this mosquito or this cockroach. Only the moth will react with the moth P-band, release moth pheromones, and attract more moths. Now, I would like to talk about our boundary assembly. As you can see, it is fairly simple. We use the constitutive promoter, an RBS binding site, our P-band DNA sequence, and a terminator. Through transcription and translation, our P-band is readily made. We named this P-band biobrick P-band SL, taking the first letters of the Latin name of Oriental leafworm moth. To know that our P-band can actually be made by our E. coli, we did a lot of testing. First, we did a PCR with the forward primer in front of the pecans and the reverse primer after the terminator. The theoretical length should be around 600 base pairs, and as you can see, it is at the correct spot, right between 500 and 750. So this informs us of a success. We also ran an SDS page gel to see the actual expression of our peptide. Through the comparison with loading control, we can see that our P-band is successfully expressed by our E. coli. Now that we know that our P-band is possible to be made inside our E. coli, we also built this other biobrick assembly tagging a VFE gene behind our P-band as a reporter gene. Again, we are indeed successful in expressing our P-band since our E. coli all give off blue light. So now that we know our E. coli can, in fact, make P-band, we want to know how we go from P-band to pheromones. So here's the mechanism of how P-band works. The P-band binds with a G protein coupled receptor with a 7-helix structure that, once activated, will change the calcium ion concentration gradient, fuel the calcium pump, and initiate the entire pheromone biosynthetic reaction. Now, we have our P-band made inside our E. coli. To cross the cell membrane barrier, we did something very simple. We mashed our E. coli along with the LV it's grown in. That way, we can release the P-band made inside from the cell and let it into the liquid. We take it to autoclave, and we obtain this bacteria-free LV P-band mix. Then, we soak cotton into our LV P-band mix and sprinkle sugar on it. Once insect starts to ingest this sugar on our cotton, it will come in direct contact with our P-band, and it will start making pheromones. Here is a video of our P-band effect testing. As you can see, this originally very still female moth suddenly began to frantically flap its wings. This is a sign of sexual stimulation. So from this point on, this female moth is starting to release pheromones and attracting more of its male counterparts. Now,
to complete the mission, a powerful weapon is necessary. So let me show you our device. Just as we previously mentioned, we hope to not only establish a new solution to insect damage currently happening all over the world, but also apply said solution to agriculture and even everyday life. For example, with backyard. You can see on the slide that our device is like a film. We choose acrylic panels as our material in order to ensure it is strengthened enough to support our device and not easily destroyed by insects. Now, let me introduce the detailed structure of our device for you. You can be divided into several parts. First, the base. At the center, design a raised spring-like structure to hold our flag, and another raised square structure for inner shell to be straight down. Next, the outer shell. It is formed by 4 equilateral triangles. The reason why we choose the pyramid to be our shape is that it facilitates draining of water and snow and prevent pounding. This allows our device to function normally in any weather condition. We also design a pyramid with its top part chopped off as an inner shell. We continue to use the pyramid shape is necessary for overall design and consistency. We also create a seriously cleaning duct for the target harmful insect to easily enter our device and unable to escape. The clustered LEDs on the outer surface of the inner shell. They are powered by a battery that will be positioned here. Okay. This is not only for making our device look good at night, but it plays a crucial role of attracting the first target insect into our device and make more film for us. So now, it's time to tell you how we use our device. To make insect helpers, first of all, we have to make insect come to us. To do so, we will use light to attract them into our device. Once inside our device, they will be led to our P-band by the sugar we coated on our P-band soft cutter. Until this point, there is no specificity in the attraction. However, once the target insect goes into our device and is its own P-band, it will release film. Then more of our target insect will be attracted into our device. Now, our harmful insect has already released its own film, so even if we turn off the light, we can still attract them into our device. Now, we have a video of our device working its magic. Take a look.
With our new method, we are trying to start an agricultural revolution. The concept is eco-friendly, easy to use, low cost, and fashionable. Our device is part of this revolution. It not only effectively captures harmful insects, but it also will become a must-have garden decor. It will light up your farm or your garden or wherever you choose to hang your device like a beacon in the night. Now, this is our device, and this is magic.
To help farmers find the best condition to use our device, we did modeling on how Oriental leaf moth will behave under different lights and temperatures. Farmers cannot control the weather or the temperatures. They can use different lights. With our modeling, they can switch on the light that will give them the best result of insect attraction.
Now that we know our biggest threat is eliminated, we are taking a step back to help the world fight the rest of its evils. All of these insects are currently wreaking havoc all over the world, and we've also constructed P-bands to solve their problems. As we can see from these SDS page gel results, we have also successfully expressed all of these P-bands.
Through our human practice, we not only took our project to the industry, but we also educate people, be they farmers or students, of the importance of protecting our environment. Our human practice can be separated into 3 criteria. First, also the most important factor of our operation is the people who support us. We cooperate with some organic farms like Qingchen and Guanglai Organic Farm to take our operation out of lab and into reality. We not only caught our target insects at this farm to complete our testing, but we also provide them with our device so they can use it and give us some feedback. Second, we had many meetups with other Asian teams. This summer, our team held a meetup, which met 2014 Asian Conference, inviting 22 teams and over 150 people in China and Taiwan to attend. In this meetup, we shared our project with each other and exchanged thoughts and ideas, in hopes of perfecting our project and also getting to know more Asians around the world. We also had a meetup with Lindau High School Asian team. who showed a tour of our lab and had a video conference with Xiamen University IT team, who were very surprised to know that over 90% of our team consists of freshmen. Third, to promote iGEM with education. This summer, our team held a biocamp to introduce iGEM to senior high school students, and also gave Salon National University, Can to visit us. Their first peek of what iGEM is all about. In addition, we talked to farmers at the Green Farmers Market fair about our project. With their everyday farming experience, they gave us a lot of useful advice, and they were very excited to collaborate and help iGEM team bring better lives to people.
Now, this year, our team created 27 new biobricks with 9 sets of P-band and 3 new biobricks in each set. So new biobricks, definitely check. We also developed a new insect control system and invented a cool device like you've never seen before. So improvements, totally check. Not only our method is currently in test use at organic farms, and we also held a conference with over 150 people and met up with many other iGEM teams. We also advertise iGEM and the awareness of eco-friendly through biocamp and green market fairs. So, human practice, gigantic double check. We would like to give thanks to all of the instructors and alumni who support us for our project, and every single team member of our team this year. This is the end of our presentation.
Thank you for your attention.
Okay, thanks for the very exciting sharing about the achievement about the iGEM's product. So let's welcome the details questions. Any questions?
我对农业不熟，这个问题就是你的产品就是GM和price 比较，然后另外也是你产品会对虫媒的作物会有害。
Okay, so the first question about the difference between our product and the genetically modified or organisms or whatever crops. So our product is an insect control system. So it is not a crop. So we are simply doing what is currently being used in agriculture, our pheromone traps, and we use genetic methods to simplify it and make it more efficient. So it's not a crop, and it has nothing to do with GMCs. And the second question about if it will affect crops that rely on transmission of insects. Well, to use our product, you have to do before using our product, we have to do an assessment of the farm to see what kinds of crops are grown here and what kind of insect damage they are experiencing. So in your case, if because our product is highly specific, so if this area is experiencing a certain kind of insect damage, we will only hunt down this kind of insect. So those insects who are helping the crops to reproduce, they wouldn't be touched by us, so there shouldn't be such a problem.
Any questions? Okay, so the girls. Okay.
Is it possible to cause natural selection for these pests so that this device might lose its effectiveness at last, maybe?
Oh, this is a very good question, and we have also thought about it in our project. And because this method is brand new, so we will still need a lot of experience to know if such a problem will exist. So I can't actually answer this question right now.
我想请问就是说，关于原土没有做费洛蒙的原因在于说，费洛蒙的合成对婴童来是一个比较复杂的情况，但是我们已经知道说费洛蒙的合成在化学上是能够做到的。那请问你可以说，相对于费洛蒙的合成，你控制批倍的这个方法有什么好处？
Okay. So a main part of this is about cost. As we know, when you want to chemically synthesize something, you will need to control the condition and apply the reagents. So we actually look up the chemical synthetic approach to make pheromones, and we found that there are a lot of temperature change and atmosphere change. So to maintain these conditions, they're very high cost. So with our method, all we have to do is just grow a plate of E. coli. That's it. So it's much more simpler. Thank you.
Okay, so any more questions? Because I'm in introduction, so I have to give the brief questions. Actually, from the industrial area, I want to ask about how the efficacy of the apparatus. If I didn't misunderstand this, your apparatus is not to use the P-band to abstract maybe the female moth into this apparatus, and they use the pheromones to attract it and others like male moth into inside, right? So how much the moth you can get inside per apparatus? How many moth we can recruit in the apparatus? How many moth?
You mean with the size of the device, how much we can contain?
Yeah, how much?
Well, yeah, that's just a prototype. So our actual device would be much bigger, probably around 30 centimeter the square cube. So we can contain probably at least dozens of moths.
Dozens of moths. So you maybe go to the only have plenty of that a lot of moths, right?
Well, actually, our device is part of our project, but as we did some investigation, we talked to some farmers, and they already have a lot of their own devices to capture insects. So first of all, their devices are much smaller than ours. So I don't think there should be a problem with the capacity of our device. And second of all, they can choose not to use our device. Simply use the P-band we created. And they're already very easy to use and convenient for them, the device they're currently using. So,
actually, I have a very interesting investment. So I have another question. It's a very big question. That actually your use of P-band, does that have any kind of the ecosystems, to grow the ecosystems? Is that every kind of problems to grow the ecosystem just because you will use the pheromone like the product, so maybe the more use of pheromones, maybe is there any possibilities that grow the ecosystem to get like
yes. So your question is that since we are eliminating certain insects, will we be like breaking the balance of the ecosystem and stuff? So, well, first, we are basing our project on the currently in use pheromone traps. So currently there aren't problems such as ecosystem being unbalanced reported with these kind of use, the use of pheromone traps. And also, one thing to keep in note is that our product is only affecting a small area, maybe within a farm or smaller, like part of the farm. So it shouldn't be affecting a large area of the ecosystem.
Okay, so let's thank the about sharing the